Hello there, myself Janil Mahendra Popat. We are today discussing geotechnical engineering, index properties, relationships and tests, video part 2. In first part, we have seen three-phase diagram, its constituents as well as two-phase diagrams. Now we will move to index properties or fundamental definitions of index properties. These are most fundamental definitions of geotechnical engineering. It is also asked in competitive exams. Let us go to the first definition, void ratio. So void ratio is defined as the ratio of the volume of voids to the volume of solids. Void ratio is denoted by small e, and equation of void ratio is volume of voids divided by volume of solids. Void ratio is again unitless because denominator and numerator both are of same unit, so it will be unitless. Let us go to item number 2, porosity. Porosity is generally expressed as percentage. Both porosity and void ratio are measures of the denseness, or you can say looseness, of soils. As the soil becomes more and more dense, their value decreases. Basically, porosity is defined as the ratio of volume of voids to the total volume, and porosity is denoted by small n. Let us move to next definition, degree of saturation. Degree of saturation is denoted by S and in suffix small r. It is defined as the ratio of volume of water to the volume of voids. So SR is equal to VW upon VV. Now, there may be two cases. The soil may be fully dry or fully saturated. If VV and VW are same, then SR will be 1 and soil will be fully saturated. When it can happen? So, in case of fully saturated soil, when the soil is fully saturated, the air will be absent there because the soil is fully saturated, full of water. Voids will be full of water. So VW upon VW. So SR will be 1. So we can say that the soil is fully saturated. Or vice versa, if soil is fully saturated, we can tell that SR is equal to 1 there. Now, in case of fully dry soil, like there is no water and voids are completely filled with air, so there will be SR value 0, and vice versa. Whenever the soil is fully dry, SR will be 0, and when SR will be 0, soil will be fully dry. Let us go to next definition, air content. So it is defined as the ratio of the volume of air to the volume of voids. Air content is denoted by small a and in suffix small c. Its equation is AC is equal to VA by VV. Now, degree of saturation and air content are complementary function of each other. How? We know that volume of voids VV is equal to volume of air plus volume of water. So, mixing both, it will be 1. I mean, VW by VV plus VA by VV will sum as 1. So, we can write AC plus SR is equal to 1. And how? They are complementary to each other. So we can also write EC is equal to 1 minus SR. Let us go to next definition, percentage air void. It is defined as the ratio of the volume of air to the total volume. Volume of air to the total volume. Percentage air void, name itself shows it is in percentage and it is denoted by small n and in suffix small a. The water content is defined as the ratio of mass of water to the mass of solids. Water content is denoted by small w. Its equation will be like small w is equal to ww upon w dry, or you can also write ws as w weight of solids into 100 percentage. So again water content is also shown in percentage. In some literature, in some books, water content is also represented as mass of water by mass of solids, or mass of water by mass of dry solid. Going further, let us go to specific gravity. Specific gravity is denoted by capital G. Specific gravity is defined as the ratio of the weight of a given volume of soil solids to the weight of an equal volume of distilled water. So we can write capital G specific gravity is equal to Ws upon Ww, in which the water we are taking should be distilled, and solids and water both should be of the same volume. We can also divide both by volume and we can write gamma S by gamma W also. Specific gravity is unitless quantity. There is no unit of specific gravity. One thing to note down that the temperature when you are measuring specific gravity should be 4 degrees Celsius. The specific gravity for natural soils generally fall to 2.65 to 2.8. As there is no unit, we will define a range, generalized range as 2.65 to 2.8. Moreover, specific gravity is again divided in two parts, absolute specific gravity and mass specific gravity. Both have little difference. Let us understand that if all internal voids of soil particles are excluded for determining the true volume of solids, the specific gravity obtained is called absolute specific gravity. And if all internal voids of soil particles are included in the volume of soil solids, the specific gravity obtained is called mass specific gravity. Moreover, absolute specific gravity is also known as true specific gravity, and mass specific gravity is also known as apparent specific gravity or bulk specific gravity. There is little exception in the range which was given 2.65 to 2.8. The organic soils generally have specific gravity less than 2.0. There is one exception. Okay, let us go to the next definition, unit weight of solids. It is defined as unit weight of solids is defined as the ratio of weight of solids to the volume of solids, and it is denoted by gamma. It is gamma. So its unit will be kN, kilonewton by meter cube. Kn by meter cube. Let us go to the next definition, bulk unit weight. Bulk unit weight is defined as the total weight of the soil or unit total volume. total weight of the soil mass per unit total volume, and bulk unit weight is defined as gamma B, gamma in suffix B. Dry unit weight. Dry unit weight is defined as weight of soil solids per unit of total volume of soil mass. Here we will take weight of dry or soil solids only, and it is denoted by gamma D. Units of bulk unit weight and dry unit weight will be same as unit weight of solids. It will be kilonewton per meter. Going further, definition next, saturated unit weight. When soil mass is saturated, its bulk unit weight is called saturated unit weight. Saturated unit weight denoted as gamma saturated, gamma in suffix SAT, and its equation can be written as W SAT in suffix by total volume. So weight at saturation by volume. Unit of saturated unit weight will be same as before, kilonewton per meter cube. Next definition is submerged unit weight. The name itself shows submerged. So when a dry soil mass is put into water, or water is put on some dry soil mass, it is submerged, not fully saturated, but it is submerged. Submerged unit weight is defined as the ratio of submerged unit weight of soil solids to the total volume. So it is denoted as gamma sub, SUB is submerged. Equation of that can be written as W in suffix sub by V, total volume. Submerged unit weight can also be written as gamma dash. Gamma dash is equal to gamma saturated minus gamma W. Now these means unit weight, saturated unit weight minus unit weight of water will give you submerged unit weight. Now question is, what is unit weight of water? Unit weight of water is taken as 1 gram per centimeter cube or 9.81 kilonewton per meter cube. Generally in books they take 10 instead of 9.81 for the ease of calculation. Bulk density is defined as the total mass upon total volume. It can be written as rho, it is rho and in suffix B for bulk, or it can also be written as only rho. Unit for this will be kg per meter cube, as this is mass, or gram per centimeter cube. Sometimes in problems bulk density is also used instead of unit weights. While solving the problems, keep one thing in mind, that is 1 centimeter cube volume will be equivalent to 1 milliliter of water, 1 ml of water. Last index property, density index. Density index is defined as E maximum minus E upon E maximum minus E minimum. Density index I is denoted by I and in suffix capital D. Now question is, what is E max, what is E and what is E minimum? We know E is void ratio, E maximum is void ratio in the loosest state of the soil. When soil is in loosest state, the void ratio will be maximum. That is why it is E max. What is E minimum? When the soil mass is in densest state, the void ratio will be minimum. Voids will be minimum in that. That is why it is E minimum. So density index is used at many places as it represents looseness or denseness of the soil. Here, when the natural state of the cohesionless soil is in the loosest form, the E natural void ratio will be same as E maximum. So ID will be 0. And when the natural state of cohesionless soil is in the densest form, the natural void ratio E will be same as E minimum. So value of ID will be 1 then. Now let us see how unit weights are proportional to each other, or how in decreasing or increasing order they are. Here we should remember these 4 things. Gamma dash is always less than gamma dry. Gamma dash is what? It is submerged unit weight. Is always less than dry unit weight. Dry unit weight is always less than bulk unit weight. And bulk unit weight is always less than gamma saturated, that is saturated unit weight. So if we compare unit weights, saturated unit weight will be highest of the all 4. So here I conclude the video. In next video we will go to relationships of this index properties. Thank you.